Okay, so this is a brief set of notes on inscribed angles. I know you all love when I say brief, so that's always good. Again, let's start with a circle, okay? And what an inscribed angle is, and I'm actually going to use maybe, I don't know, let's see, line tool there. Haha, there we go. And another one there. Is a little different from a central angle. So before, when we were drawing angles, we would draw it to the center of the circle, right? Which was to here was where the vertex is. But now the vertex is actually on the circle. Okay, so let's take a look at what's going on here. When I have an inscribed angle, the relationship is a little bit different. It's no longer the same size as the arc. So let's say the arc here was, I don't know, let's make it 80 degrees. Let's say that that's an 80-degree arc. Then the inscribed angle will actually be half of that. That angle will be 40 degrees. So the measure of the inscribed angle is half the measure of the intercepted arc. Now, there's a couple quick corollaries that come from this. Like, let's make that straight. I have found better tools, so let's do that. There we go. So like if I inscribe another angle from the same arc, like this one, lo and behold, those angles, this one here, since it's intercepting the same arc, have to be the same size. So two angles that intercept the same arc are congruent. Okay, so let's take a look at a couple of other special situations here. Okay, so this next one is one that they really love for things like the SAT. Oh, that's not good. Let's do this. There we go. Yep. Don't hit the big button. All right, so my stylus got a little bit of the best of me there. All right, there we go. All better. All right, so one of the things that the SAT likes to do is draw a diameter. Okay, so find a way to draw a diameter. And then what it does is it inscribes an angle inside that diameter. Okay, and why does it do this? Because weird things happen here. Is that remember that since this is a semicircle, this is going to be 180 degrees, the arc, which means this is forced to be a 90-degree angle. And once you have a 90-degree angle, you have like the Pythagorean theorem and all of that kind of thing. So a angle that is inscribed in a semicircle, or whose ends are the endpoints of a diameter, is going to be a right angle. And like one of the things that like they could do with an SAT is say, hey, this is 5, right? And let's say this is 6.5, and ask you what this is, right? And 6.5 and 6.5, because that's 2 radii, is going to make this 13, which now makes this a 5, 12, 13 right angle. But they don't have to tell you that that's a right triangle. They don't have to tell you that's a right angle. They just have to say it's inscribed in a diameter. So just be thinking of ways that like standardized tests could be leveraging this fact. All right, so let's get at the last little bit here. Okay, so in this last one, let's say I have, not an oval, let's make a circle. There we go, a circle, right? And I grab and put 1, 2, 3, let's put it there, and 4, and I inscribe a quadrilateral inside the circle. And I want to look specifically at a pair of opposite angles. So this one here, let's call that measure X. Let's take this one, measure Y. Now note, those are 2 inscribed angles. The Y angle is this arc, right? So maybe we'll call this M. Y is 1/2 of M, and X belongs to this arc, right? So this one going around this way. Let's call that N. X is 1/2 of N. So note, if I take the arc measure M plus the arc measure N, that's 360. Because that's a full circle going all the way around. So if I take half of these, I'm going to get that the inside angles, X plus Y, are going to be 180. So if you inscribe a quadrilateral inside a circle, the opposite angles have to have a sum of 180, which means they're supplementary. Okay, so there you go. This is inscribed angles and circles, and that's it. We'll work with these in class tomorrow.